Okay, let's get started again. Today's lecture is on smart services, which is a really exciting area of service design. You might own a Fitbit, you might own a smart watch. All sorts of things are happening both with technology and business model innovation in the last few years that make this a really fascinating subject. Historically, most service systems were based on what we might call passive resources or static resources, where you had to act upon them or interact with them to get any value out of them. But we're now seeing that if we add a sensing capability or a computing capability or communication capability to a resource, we can make it progressively smarter and enable it to create value on its own or by interacting with or invoking passive resources. The simplest way to make a resource smarter is to use location, which is now very easy to know with your smartphone. And we have a lot of things which are smart because they're connected to the internet now. So we have smart plants and smart forks and smart all kinds of things. Any resource with an internet protocol address is said to be part of this Internet of Things. So you might have seen on TV or elsewhere ads for the IBM Smarter Planet Initiative. This is the major undertaking of IBM. Their logo is this, which is from a t-shirt that they gave me. I probably should have worn that t-shirt today to record this lecture. It's not entirely clear what these symbols mean, so I'm going to try to use them to start to talk about what makes something smart. The basic thing that makes something smart is that a resource can sense something. The resource can sense, measure, track, or otherwise record some aspect of its environment or context, or how it interacts with other resources. Now, there are a lot of different dimensions of this sensing. We can measure physical properties like temperature. We can measure motion, acceleration, velocity, and so on. We can measure various properties of biochemical or other kind of things. But sensing by itself doesn't really add any value. Something needs to be done with the information that is sensed. And a part of that is knowing where it was sensed. So a very common term in the discussions of smart services is the concept of context awareness. And you hear that a lot, but unless you define context, it isn't very useful. So let me try to define context in a very straightforward way with some specific questions that a context-aware resource or service might try to answer. So you'd say, where are you? What are you doing? What are you looking at, looking for? Who's there with you? What's it like there? So you can see this could be operationalized to being location information, information about point of view, orientation in an environment, some kind of compass orientation. It could be distance to some object. It could be who you're with. You could imagine using if each cell phone can identify itself, you can identify the people in an environment by identifying their cell phones. You can identify the temperature, the wind, whether it's daylight or not, those kind of things. What is it like there? These might be some of the aspects that would tell us what context is. But the simplest contextual parameter is simply location. And this is something which we're all familiar with because our phones can use location about the phone to personalize or adapt the outputs. Now, in fact, identifying location is actually a very hard thing to do. It's much harder than, say, detecting the temperature, which an ordinary thermometer can do. But our smartphones are able to detect location very accurately because they're tied to wireless towers, which are in a very fixed location. We can triangulate very easily to figure out the location of the phone. So many providers of applications that run on phones, like say for weather or for searching for restaurants or something like that, are going to use location-based search, and they'll default or localize the search to the location that the phone is in. So if I search for coffee shop and I'm in San Diego, it wouldn't do me any good to get coffee shops that are located in Seattle. I'm not going to be able to go get a cup of coffee at that coffee shop anytime soon. So you're probably used to seeing maps like this on your phone where you search for something, and here you are standing in my office in the Berkeley campus saying, where's the coffee shops around here? And it gives me the list of the coffee shops and tells me where they are relative to my location. Now this, in fact, is quite amazing because you're so familiar with this kind of mashup where you use location information on top of a map. It's hard to believe that 10 years ago when this first happened, The first response of Google, the provider of the map, was this was illegal, and they would not let people do this. Now, they changed their mind when they realized how much value could be created in location-based services by letting people do this kind of combination of information and the map. Another very common idea in location-based services is with augmented reality, where you overlay some information from some knowledge base. It could be Wikipedia or something like that on top of the location of your smartphone, so you can see the actual scene in these three applications, the transit app of San Francisco, Wikitude, and Layar, where we're overlaying information on top of the picture of where you are, so you get direct orientation about the objects in your site. Another way to make a service smart, based on context, is to track location and activity. So if we identify an object in some location, we could use that information, say, to pay for a toll at a bridge. You may have a transponder in your car or your folks' car that you use when you cross the bridges to pay the bridge tolls. We use this to track packages when we deliver them. So object identifying the location is a really important kind of idea, and it's essential in doing business because knowing where things are is the key to being efficient about building things and selling things and getting things to customers at the point when they want to use them and buy them. So here's a question for you. You've all seen those brown UPS trucks many, many times delivering packages. What do you suppose it says on the side of that truck? I'm sure you're thinking, oh, it says we deliver your stuff or something like that. And the answer is no, it doesn't. It says synchronizing the world of commerce. Because in fact, UPS makes a ton of money, by delivering, but it makes a ton of money even more by helping companies design and operate their supply and delivery networks. Delivering stuff happens to be the easiest way to know where things are, but that's almost a side effect of being able to be in the business of helping people plan their delivery networks. All right, as I said before, knowing where something is, or being able to sense something, is only important if you can act on that information. So an important next step of being a smart resource is to be able to actuate. That means that the resource can initiate some action, maybe able to turn on some other resource like lights or motors or speakers or cameras. A security camera may be turned on by motion, for example. Okay, that device may be capable of displaying or broadcasting, otherwise sending information about its state. So when you wave in, when you have a device which is RFID enabled, that's radio frequency identification technology. When it gets past a receiver, it basically identifies itself, and that's how your fast track works, and that's how you would be able to, for example, track lettuce as it's coming from the fields going to the store, which is important if you want to figure out where that E. coli outbreak started. But we're making not just physical resources smarter, we're actually making animate resources smarter. So there's a new application called Tag, the dog tracker. The dog tracker, you put a location tracking collar on your dog, and you can define some region where the dog is supposed to stay, and if your dog runs out of that region, it will send you a text message. So you're being notified your dog is now enabled to be a smart resource because it has this sensing and communication technology in its collar. Now, you could ask a deep philosophical question here about whether putting the collar on the dog, does that make the dog smart, or is it just the collar is smart and the dog is still dumb? What if you implanted this under the dog's skin? Is the dog smart now as a part of the dog? I think we should just focus on the value creation by the dog-collar combination and leave that question to the philosophers. But it's an important issue because as we get really, really smart, we're blurring the lines between people and machines. These questions will be more and more important to us. So here's a smarter cow, or maybe just a cow with smart technology on it. But you all know what sex messages are, probably. Well, this is a cow that can sext. So a really important business problem for people that have cows is to make sure they don't miss a estrus cycle when they are in, quote, in heat, when it's a good time to have them be inseminated to have calves and stuff like that. So if you miss that cycle, then you lose a lot of money. So we're now putting sensors in the appropriate places in the cow, And when it detects that the cow isn't heated, it sends a text message to the manager who can take appropriate action. I'll leave you to speculate on other applications of that kind of technology. But the obvious one is to treat people with sensors and have them activate messages when they have certain kinds of physical states. So we're seeing a lot of developments in remote patient monitoring technology where you put various kinds of sensors or assistive technology. You sort of put the collar on grandma, to be bluntly about it, so that you can let her age in place rather than having to be in a nursing home. And that can vastly improve the quality of your grandma's life, where you're having various kinds of services that is both to assure you that your grandma is okay, to maybe compensate for some impairment grandma has, or to otherwise assess how grandma is doing. And this remote patient monitoring is really quite fascinating technology. Essentially, it's going to be a big growth industry for all the baby boomers like me who are growing old. Now, I'm not ready to strap on sensors and have my doctor monitor me 24 hours a day, but at some point maybe I will. The basic idea is that you have these wearable devices or home appliances that capture vital signs. When you step on the scale or things like that, it can measure some aspect of your situation, take your blood pressure, so on, and send it to your doctor. This picture from an ad from Philips Telemonitoring Services shows a very high-tech kind of service system where you have lots of different devices that are monitoring essentially the quality of the interactions that the person is having in their house and the quality of their health. But there's actually fairly low-tech ways to do the same kind of things. I mean, you can imagine making inferences about how your grandma is doing living alone by monitoring things like her refrigerator door, the TV set. If your grandmother typically watches TV several hours a day and the TV doesn't turn on for a couple of days, then maybe something's wrong with grandma or the TV. Or if the refrigerator door hasn't been opened today, then you know something's wrong with grandma because she hasn't eaten today. So that whole area of assisted technology and remote patient monitoring will be very, very important, and it may be places where your generation can make some really important contributions to my generation of old folks. But again, it's not just sensing. We have to be able to connect and do things, or otherwise it's just knowledge for knowledge's sake. So being able to connect and send these messages is really a critical part of making a resource smart. And again, it's sometimes you have hardwired connections where you may have a device which has one purpose and knows how to send a message of one kind to one place. But you can imagine more flexible or loosely coupled connections where you can use an internet protocol to send a message to any service which is interested in getting that information. So that would be a very, very flexible thing. An important issue there, though, is whether those kinds of sensor apps that we build that can communicate will be communicating in standard ways or proprietary ways. One fear I have is that you'll see lock-in from vendors like Google or Apple, which will build their set of smart technologies for assisted living, let's say, but they'll only be able to talk to certain hospitals or certain vendors. So suppose Apple and some hospital merged, and you are locked in, and you can't change hospitals because you're an Apple customer, that kind of thing. So you see that having open standards could be really important there as we build smarter service systems. And again, the next step beyond connectivity, I believe, is computation. It's not enough just to collect the data and send it. It would really help to be able to analyze it and refine it and learn from it. And some devices are able to do that. And that's really important because you can imagine something like your car fast track. It might be constantly broadcasting its location, and so there's literally billions and billions of data points being produced. You have to be able to decide which are the significant events in that torrent of data. And one way to do that is have very smart technology to analyze it when it's collected. Another way to do it would be to make it smarter when it's sent. So doing analysis at the moment it's captured only sends the significant events in the first place. My favorite example here of these sort of learning resources is the Nest thermostat, which some of you have heard about, where Nest is a company which was recently bought by Google. And many people have programmable thermostats on their home, but very few people actually go to the trouble to program them. So what Nest does is it has sensors to do the usual thermostat kind of functions, but it can also talk to, using a Wi-Fi connection, to local weather data and things like that, to use that as a way to calibrate what it should be doing. And it also learns from the people living in the house as they set the thermostat coming and going, that if they forget to set it, it will just learn to do the right thing. They know that it'll turn itself down when they go to work and so on, and turn it on before they come home and things like that. So this ability to learn is really important, but it's still only learning to do things it was taught to do when it was programmed. So sure, my Roomba vacuum cleaner knows how to navigate around the house and avoid obstacles, but it can only do vacuum cleaning. I think the next generation of devices will learn to do other things. Just like I can download an update to my app on my phone, I'll be able to download a new set of things I can learn to my smart resources. And finally, the last step of sort of smart resources is the ability to compose and cooperate between resources, where independently designed and deployed smart resources can work together to do even more smart stuff because they're combining what they know. So here's a map of San Francisco on my Google Maps app, and you see that it's showing traffic congestion. Green means good, red means crowded. Well, how does it know that? Well, people who are using that app, Google Map on their smartphone, are essentially broadcasting back to Google their location over time. And so if your location doesn't change over time, it means you're not moving because traffic is stopped. And if you're moving very fast, your location information will differ quite a lot between successive times talking to Google. So information aggregated and analyzed is then sent back to your phone as the traffic congestion information, the overlay on top of the Google Map, which is really kind of fascinating. Well, that's just the beginning of smart cars. Smart cars that come, the only question is what they'll be able to do and when they'll be able to do it. Because if cars they'll be able to help each other drive faster with less congestion, not crashing into each other. You've already seen the Google smart car. Well, what if all the smart cars can work together to create a kind of aggregated smart car? You really have some really tremendous benefits in the quality of the driving experience and traffic jams as we know them today. So again, we're also starting to do this kind of aggregation about people. There's a company that is looking at how to improve the work experience by tracking people's interactions at work. Here you see an employee wearing a sensor sort of badge that's called the sociometric badge that tracks through sensors their movement, their talking, where they are when they talk, the tone of voice, and a number of other parameters which can be analyzed, as you see on the picture here, to see patterns of interaction. So here you see, I mean, we know that it's pretty common sense that people who send a lot of email messages probably don't have to talk to people face to face. But it turns out that in this company, people on the second floor talk a lot on email but never talk face to face, and the opposite pattern is true on the third floor. So something very different is going on those two floors where they have different patterns of interaction. Maybe that's not optimal. So we could intervene there and say maybe people should talk to yourself once in a while face to face rather than only sending messages to each other. That's probably a beneficial application, aggregated data. Some of them are not so beneficial, and I urge you to think twice before you build these kind of applications if you have this as an idea. A really bad idea, I think, is SceneTap, which combines video cameras and some smart image recognition software to recognize some characteristics of people, like is that a man or woman, is it young or old? And these cameras are deployed in various bars and restaurants in cities like this is the map of San Francisco, and they tell you essentially about the activity going on in that bar. So this particular screenshot is showing that a bar near my house in San Francisco is crowded with young guys. And what you would do with that information, I'll leave it up to you, but I think it's a little creepy that you could know something like that about a bar that you're not currently in. Now finally, something sort of surprising happens at big scale. So we've shown a lot of situations where progressively smarter resources are able to add progressively more value, but something interesting happens if you measure everything. IBM has been promoting the idea of smart buildings and smart cities and things like that with lots of sensors. And what's interesting is that doesn't always require that everything's be very smart. What you start measuring is that you're just trying to measure what normal behavior, what the normal sensor readings are. So you measure the flow of water through a pipe, or the temperature in a room, or the amount of electricity being consumed in some place. And you do it all the time. you get some baseline information about what normal kinds of situation is. So then if something goes wrong, you can see that the numbers are different than the baseline. And you don't have to know anything about the numbers, what they really mean, but you see something's different, and you can then look and see what's causing the problem. So monitoring of a very complex system with lots of sensors is actually a really important innovation. It doesn't require as much smarts as you might think. So let's conclude. I mean, I'm a big fan of smart services, but there's some limitations that you need to be sensitive to. One is, as I said before, not every application is sort of socially appropriate. And it's related to the fact that some services may require you to give up information about your current or previous context that you may not want to give up because there may be some privacy considerations. You certainly don't want to be spammed by or stalked by a service provider based on their knowledge of your typical behavior and locations and so on. But frankly, those kinds of worries are probably minor compared to potential abuses by governments. So imagine what a government that doesn't respect civil liberties could conclude about the innocent owner of a mobile phone who has received calls from people from various parts of the world that might have a lot of dissidents or people we don't like in them. So we could use location-based tracking to make inferences about you that may not be correct. Again, there's a great deal of hype here about the Internet of Things. Again, but I'm optimistic about the innovation going on. In fact, it's hard to keep up with. So if you search for the phrase Internet of Things, along with almost any physical resource, you'll find something. So you could look for Internet of Things dog, we already talked about that, fork, lettuce, pajamas, street lamp, and try a few of your own, and you'll see how much of the world is being made smarter with smart services. Okay, see you next time.